Good afternoon, everyone, and welcome to Monash DeepNeuron's first AI Futures webinar. My name is Sahil, and I'll be your co-host for the first half of this evening. I'm also joined by my colleague, Stephen, who will be your Q&A moderator for the second half of our webinar session. Now, I'm super excited to be hosting this event today because we have about 250 registrations, including a majority of students from Monash University studying engineering, IT, science, medicine, and commerce, to name a few. We also have a roughly even split between all year levels, so we do have quite a diverse bunch today. As you all know, this event will be running from 3 to 5 p.m. We are going to start by asking the panelists some questions that the organizers here at Monash DeepNeuron have collated. That will go for roughly an hour. And then I will be handing it over to my colleague, Stephen, who will be taking questions from the audience. But before we start all of that, I'm going to hand over to our team lead, Rebekah Chiu, who will be introducing Monash DeepNeuron itself. Thanks, Rebekah.
Thanks, Sahil. Let me also add my welcome to all of you who have made it today, and an especially warm welcome to all our panelists for this Q&A. As Sahil mentioned, I'm Rebekah. I'm the current team lead of Monash DeepNeuron. If you aren't familiar with who we are or what we do, we're an engineering student team based at Monash University. As a student team, we're fully organized and led by a team of students, including myself, and we all have a passion for AI or high performance computing. Our team is multidisciplinary. We've got students studying a range of degrees, including engineering, IT, commerce, medicine, and arts, just to name a few of them. They come from a variety of backgrounds, and they're also a mixture of bachelor's, master's, and PhD level students. We started with a focus solely on AI, but more recently we merged with the Monash Student Cluster Competition team about late last year, and we've also expanded our focus to include high performance computing. As a team, as you can see on screen, our vision is to empower students and researchers to use artificial intelligence and high performance computing through ethical and hands-on research projects. We engage and educate the community through outreach events to promote the accessibility and awareness of AI and HPC in the public. To give you a better understanding of what we do, I'm going to quickly go through some of the projects our students are currently working on. The first project team we have here is our CT Facial Reconstruction team. They're working on using a generative adversarial network to reconstruct faces from skeletal remains. These remains have been imaged using computed tomography, and this has applications in forensic science, in assisting with identification of decomposed bodies. Our next team is our Dynamic Balancing Project team. They're working on applying reinforcement learning to dynamically balance gameplay. The idea of this is for people who might not be very experienced in gaming or haven't played a certain game before. It's for those people in particular to match the difficulty of the opponent in the game, such as Street Fighter, where there isn't much of a tutorial, with the user themselves, so that the user is given a good challenge and an adequate challenge to make the game enjoyable, but not too difficult for a beginner coming into the game for the first time. Our next team is our newest team. They're working in microfluidics, using image processing techniques to identify male infertility and also assist in improving IVF techniques. Infertility is an issue that's continuing to increase around the world, so it's definitely a matter of global health concern. So the team is working on using imaging techniques to take the guesswork out of selecting sperm for IVF and also to help in determining the fertility of a male from a sperm sample. We have one final deep learning project team at the moment who is working on power fault detection. Traditionally, when a fault occurs along a power line, a team is sent out to drive along the line to locate the exact location. Our team is working on using deep learning to determine the exact location without having to do that drive, and also identify the type of fault so that the team going out can repair it more rapidly and efficiently as they have knowledge of where it is and what kind of fault it is. As I mentioned before, we also have a high performance computing project team now. They're currently working on drone photogrammetry, currently collaborating with the Monash Drone Discovery platform. They're building a more efficient image processing workflow for drone imagery. They're tackling the big computationally challenging task of building 3D models from 2D images, and they're aiming to implement a software interface which enables this processing pipeline to utilize high performance computing in the back end to optimize and hopefully speed up this process as well. Before I hand back over to Sahil, I'd also like to let any Monash students in the audience know that we're currently recruiting, but we are finishing up our recruiting really soon. So I encourage you to get your applications in as soon as possible. So now I'll hand over to Sahil to introduce all our panelists.
Great, thanks, Beck. So we have 5 panelists with you today. You can see them all on the screen in our slideshow. So from KPMG, we have Dr. Sanjay Mazumdar. Dr. Sanjay is the Chief Data Officer of KPMG Australia. In this role, he is responsible for the data strategy for the firm and leads a Centre of Excellence in Data, Analytics and AI. In 2015, Sanjay was listed in the Australian newspaper's top 100 innovators as a big data pioneer. I'll actually give you guys the opportunity to introduce yourselves a bit more in depth. So I'll just be going through you one by one. From Eliiza Consulting, we have Liang. Xin is the lead machine learning engineer at Eliiza. She has worked with technologies such as computer vision, natural language processing, signal processing, web and product development. Eliiza is a machine learning consultancy operating in Melbourne, and their mission is to create a bright future for Australian businesses and society in a world increasingly influenced by intelligent technologies. Next up, we have Kenneth Young from Accenture. Kenneth is a consulting development analyst in the Accenture Applied Intelligence practice. Accenture's Applied Intelligence practice is Accenture's solution to help businesses scale their operations through data analytics, AI, and automation. Next, we have from Amazon Web Services, AWS, we have Robert Koch. Robert is an associate cloud developer at Amazon's Web Services. He used to be president of Wired Monash from 2016 to 2017, so there is some chance that you guys might recognize him. And finally, from Monash University, we have Dr. Levin Kuhlmann. Levin Kuhlmann is a data science, computational neuroscientist, and neural engineer. His research areas include data science, machine learning, signal processing, control theory, and computational neuroscience. Computational neuroscience applications into digital health, neural engineering, and neuro imaging. So that's all our panelists. We are gonna start with Monash DeepNeuron questions. So welcome everyone to our panel. The team at Monash DeepNeuron are pretty excited to have you here today. We have prepared some questions for you, but we'll start by saying, could you please briefly share with us your journey from university to the role that you are currently in today? Could I start with, let's say, you, Robert?
Sure, thank you, Sahil. Yes, thank you, everybody. Hello, yeah, my name is Robert, and I'm a cloud architect at Amazon Web Services. So I guess to start off, I applied for, when I was back at university, I applied for a lot of different internship positions, and that's kind of, I think, where it started out, and mainly just because I wanted to have a better understanding of what the tech world was like. And I think it was through that I started to find a lot of graduate opportunities as well, and sort of the idea of which companies that I would be interested in working for. I applied for the role at Amazon actually in my final year as well, and I went through the interview process, and I think that was probably the most direct. I had probably the most direct route into this job because I obviously got it, and I've been working in this position for about 18 months now. So that's how I kind of got here. It was a fairly straightforward process. I applied for it and I started to get hired. And yeah, that's how it began.
Nice. What about you, Kenneth? As you're also pretty new to the industry, I'm guessing.
Yeah, so relatively similar to Robert. Also, hello everyone. Good to be here. I think we've got about 120 people in the call now, so it's a fair few. Yeah, so again, similar to Robert, I finished up uni 2017 and was applying for some internships over the summers of my last couple of years there, just to get a better idea of the industry. Like, I guess one thing I'll add to what Robert said, not just find out where I liked, but where I didn't like. That's sometimes very important. And after I realized the amount of like opportunities and the sort of speed of growth that there was in the tech area, definitely somewhere I wanted to pursue further. So I applied for a role at Accenture, and I got that one, started with them about a year ago now, and I've been in their applied intelligence practice doing various data science analytics roles since then.
Nice. And what about you, Xian?
Yes, thanks, Sahil. Hello, everyone. So I'm Xin, later machine learning engineer from Eliiza. Eliiza is, as Sahil mentioned, it's like a AI and machine learning consultants company. In terms of my journey, I guess I probably took a different route than Robert and Kenneth. I chose to kind of like stay in more like a smaller organizations. So I start my kind of like machine learning AI journey earlier as like my final years as the thesis project. I used kind of like a artificial neural network and apply that to some heavy machine operation work. And then since then, I working in mining technology companies to actually apply like a machine learning AI into a mining industry. And then I got out of it and moved on to a more like a startup. So I've been working in a couple of startups after that, one's focusing on computer vision image search engine, particularly for trademark. And then after that, I jumped from computer vision to more NLP, working for a startup that actually focusing on speech analytics for call center calls, to call centers core analysis, and apply like heavy natural language processing techniques as well as like audio processing. And after that, I joined Eliiza as a little bit from the product company to like a consultant company, and made heavily focusing on machine learning, deep learning, and AI, and try to see how those techniques can apply to like a broader industries, not just focusing on one like product startup company, but more like how that can be applied to a broader industry. So here I am in Eliiza as the lead machine learning engineer.
Nice, thank you. That was really interesting. We've also got two more panelists, so let's go to Dr. Sanjay. Would you like to introduce yourself a bit more formally?
Great, thanks Sahil, and welcome everyone. It's great to see so many people interested in AI, data science and machine learning. So my journey started back in the 80s. So I did my electrical and electronic engineering degree between 87 to 1990, and then did my PhD in the use of artificial neural networks in control systems in the early 90s. So those of you who've been following neural nets and this whole area of machine learning will know that the sort of seminal paper in neural networks is a paper written by Geoffrey Hinton from University of Toronto in about 1986. So I sort of was doing my PhD right when neural networks was at the cusp or at the bleeding edge of technology. And back then it used to take you, weeks, literally weeks, to train your network. So been working in this field on and off for quite a while now. From my uni days, I went and worked in defence. So I was working for a Defence Science Technology Organisation, where I was working in bunch of different areas, including UAVs, including communication signal processing, including missile guidance and control, and was actually using sort of neural network techniques back then. Moved to Motorola, where I was at Motorola for about 8 years, where I was leading a team which was developing mobile commerce applications. So not in the area of machine learning, but mobile commerce applications. And this was sort of late 90s, early 2000s. .com bust happened and sort of the whole IT sector changed. And I moved to defense. So I went to BA Systems, where I worked for 10 years. And I was the head of engineering at BA Systems. So responsible for all the engineering folks at BAE, just about 2,000 engineers across the country. From BAE, I started my own, what's called a cooperative research centre, and we were basically doing AI-enabled solutions particularly for national security. So looking at deep learning, image, computer vision, sentiment, all that sort of stuff, primarily for national security applications, but also looking at other sectors as well, like agriculture, manufacturing, and health. That CRC resulted in 2 spin-out companies, both of which are actively growing. So one's called Fivecast. You can look it up on the web, fivecast.com, and the other one's called Inquiry, NQRY.com. After the CRC finished, I joined KPMG as the Australian Chief Data Officer, and basically I lead a team which is the Centre of Excellence for Data Analytics and AI. So we're developing AI platforms and applying them to real-world client problems. So that's me. So I've been in the field for about 30 years, seen the ups and downs, and we're definitely on a real up. And I think data science, AI, ML is the engine behind that upward trend across all sectors. So you're in a really, really interesting field that's got huge opportunities.
Great. And lastly, we have Dr. Levin, who's from Monash University. Go ahead, Dr. Levin.
Yeah, thanks for having me here today, Sahil and the team. Yeah, so I basically knew when I was 17, I wanted to know how the brain works and how it gives rise to my mind or soul. And so I ended up doing neuroscience with as much maths and physics and computer science as I could do undergrad. And then I did a PhD in neural networks. And then I sort of spent time during my honours thesis with the Bionics Institute, which is now called the Graham Clark Institute of Medical Bionics or something like that. But basically I went and did my PhD overseas, and then I came back and worked with those guys, and they started doing epileptic seizure prediction. And so I moved from studying vision to studying epilepsy and brain implants and trying to do seizure prediction. And so I had a few different research projects on that. But all the time I've been interested in how the brain can produce conscious experiences. So I sort of transitioned to studying anesthesia and the mechanisms underlying anesthesia through imaging. So there's sort of different prongs in my research that involve machine learning in different ways. And then eventually I landed this faculty position at Monash.
Well, I love this bunch of people because we've got really young as well as really experienced
really old
in the field. Yeah, I didn't want to say that.
I understand.
Yeah, so that's really nice to have. So I just wanted to remind you guys that I don't want this to be like an interview. So if you guys have any questions for each other, or if you guys have any comments or additional things, please just chip it in. Don't feel like if I haven't pointed at you or if I haven't, specifically asked you to talk or anything like that. I don't want to sound like some moderator here. Anyway, so let's start. So we've got a few more questions regarding your past. I guess the next question is like, what is the most influential reason for your career choice or your decision to move into AI or the field of machine learning if you weren't already? As you, like, for example, Dr. Levin, you've said that you've gone from, you know, like neuro to AI. AI to neuro. So I was wondering, yeah, could we have some discussion around that? Would you like to start us off, Dr. Levin?
Yeah, well, I got into the field of brain science because I wanted to know, if God existed and what my soul was, if I have one. And I can't answer those questions really. But the scientific way of doing that is through studying the mechanisms of consciousness, like how we can have experiences of the world. So that sort of answers the first question. What was the second question?
Was there any like changes in what you initially wanted to do to what you are doing now? I feel like it's relatively the same in your case, but just in case.
Well, there's a lot of competition in academia, applying for grants and everything. So it's very challenging to get to faculty positions. And also, if you want to study things like consciousness, it's more esoteric. So you can't necessarily get there by, studying it directly. You have to be willing to study other things,
yeah, like
and build up that knowledge. So, I mean, the PhD was about, trying to study the computational mechanisms of how the brain's able to perceive three-dimensional objects. So that's sort of, more, practical for computer vision. But it was still trying to understand how the brain does it. Whereas, when you're dealing with AI, you don't necessarily care about modeling the brain directly. You're willing to take mathematical shortcuts that are more computationally efficient or more have more simplicity analytically.
Yeah, that's cool. Should we go to Xin?
Yeah, sure. I did electrical engineering for uni as my undergrad degree, and back then I couldn't say that I knew what I wanted to do, like especially in the first 2 years. And then I got to a point that I did communications and signal processing, image processing, and then I just found like my passions. So like that's exactly what I want to do. I want to because I was also relatively good at maths, and I want to be able to kind of actually apply maths and engineering into something that I could see like magical things happened, and that I got that feeling with like image processing and signal processing. And after that, I kind of like got an opportunity to work in the like an industry research project, and to be able to I got introduced to artificial neural network, and I would just like it just like blew my mind in terms of like what it can do, and it can be applied into like something like that research projects in like a mining technology industry. So it just those two things didn't really like go together in my mind back then, but I could just apply something like artificial neural network and modeling maths into something that I could into like a heavy machinery operation or like a control system, and that would just I was just so fascinated by that, and I was just like, yeah, that's like definitely something that I want to like pursue and go further. So I would say for my decision to work in this career, it's just really that passion that I found along the way, and something that I want to go deeper and explore further. And yeah, it's just really down to like my passion.
So it was while you were working through your different jobs, you found out like you developed that passion rather than
I guess that sorry, that passion just was sparked at uni, and my final project that I got to introduce this piece of work. And then after that, I kind of yeah, this is the area I want to focus. And then I kind of steer myself towards a different, well, in the same area, but different subdomains, so I could explore more. So I did a little bit more operation research for my research master degrees. And then I kind of steer myself, because I know where I want to go. I try to steer myself into more computer vision image technology. That's why I got out of my first job and then moved into a startup to do image search. And yeah, same path after computer vision, kind of try to steer myself to the NLP area and so on and so forth. So I have the initial passion, and I knew that that's what I wanted to do, and I just keep steering myself along that path and try to go deeper.
Great. Let's head on to Robert. How about yourself, Robert?
Yeah, so I kind of started out as a bit of a machine learning skeptic when I was in university, and part of that I think came from not really understanding it. But so for context, I was doing a double degree of electrical engineering and science, and I was doing computer science as well. So I actually got exposed to the machine learning aspect actually through electrical engineering, through actually, if any of the Monash students are listening to a unit called Intelligent Robotics. And at the time, there wasn't really a lot of machine learning stuff in that. And I was okay, yeah, whatever. It's, you get computers to think, right? Thought it was a bit of a fad. But I actually did my final year project around neural networks, and it was kind of wanting to understand them a bit more. And I started talking to some friends who were also doing some sort of similar units at the time. Yeah. And that's really what piqued my interest. And I went, oh, actually, there's something here. And then I started to do a lot of, and then in my final year, I did a lot of units around it. And I was really hooked into it because I started seeing, oh, wow, there's so many possibilities to, solving problems with this technology. And it's just the horizon seems so far, so much content that you could go into, and there is. And having that sort of, seeing, all the solutions that were coming out, that really really influenced me into trying to go in and seeing what else that you could do in that area. Yeah.
That is, I feel like that's what I'm doing as well right now, to be honest, because I'm studying engineering, but I've joined Monash DeepNeuron, and that's piqued my interest in neural networks as well. Let's head over to Kenneth. What is your response?
So I was doing my a master's in mathematics with a lot of computer science along the way, and it was quite theoretical. I was the type of person that really wanted to have an impact on real people's lives, really, do work which I could see the results somewhere affecting people. But when you start to do maths, you start to write a thesis for a year or two in some theoretical area of mathematics, you start to lose that connection a bit. My master's thesis was on operations research, so definitely the businessy side of mathematical optimization, so closer to affecting the business processes in real people's lives, not the pure mathematics end of the spectrum. But I definitely felt when I was coming to the end of my master's, I wanted to get more have more direct influence on outcomes in people's lives. So I was thinking I could continue with this academia thing, continue reading some journal articles and outputting some theoretical results. But I thought dipping my toes into industry might give me a bit more of a holistic understanding of the possibilities out there. So
do you think that's helped?
Absolutely, yeah. I've been part of 4 or 5 different initiatives in my first year with Accenture now, and some of them the turnaround from initial engagement with a potential client, they come to us with a problem, and then it's sometimes 6 weeks later we have a working prototype which maybe there's some problems, but it sort of wows them and shocks them about the sort of like the amount of things that you can achieve in such a short period of time, and that, you know, just the smiles on those people's faces is really what I live for. And
Sure.
I think you know, you can get that from academia, but there's slightly more of a disconnect in my experience, at least, which maybe isn't too much yet.
Sure. Okay. How about you, Dr. Sanjay?
All right. So some similar themes there. I mean, I guess as a kid, I was always interested in tech. I was surrounded by, my dad was a professor of maths at Adelaide Uni, so I was surrounded by PhD students in maths. But I sort of chose engineering because I wanted to solve real world problems. So apply the maths, apply the physics to solving problems. When I sort of moved, well, when I did my PhD, I chose neural nets, but chose it in a field of where I could apply it to a real world problem. So applying it to solve, you know, control systems problems. And the reason I chose neural nets is because it was, at that stage, it was a new and evolving field. No one had really done much work in it. I sort of went out into industry, similar comments to the others, because I wanted to solve real world problems, develop product, all those sorts of things. So that's why I moved out of defense science research into Motorola. And I came back to sort of this whole neural network, machine learning, data science area when I founded the CRC. And really for me, it was a case of, well, now we had the availability of data, we had compute power, and we had some applications that could only be solved by using, you know, large data sets, you know, big data techniques. And so I guess that's the reason why I sort of moved back into it, because I could see the real opportunity to once again solve real world problems using these sorts of techniques.
Yeah. No, that's really cool. So everyone here has basically done some form of postgraduate studies. Is that correct? I think Robert was the only one who had it. Okay, yeah. No, that's pretty interesting. How about we go to our next set of questions, which is to do with the present or the current, like what you guys are currently doing. So our first question is, how is your company currently involved in data science and AI? Now, I want to start with you, Kenneth, because a lot of people don't know about Accenture's applied intelligence practice. And so would you please tell us what is Accenture's applied intelligence practice?
Yeah, so there's 500,000 people that work at Accenture worldwide. We've got 4,000 or 5,000 in the Australia region in sort of in the applied intelligence area or in the like sort of supporting structures. But, you know, we do everything from, you know, data analytics, machine learning, data engineering. We have a whole team dedicated to responsible AI. So they do a whole range of things. It's really like whenever we engage with our clients, it's always part of the conversation. Like, how can we work in data science techniques and analytics, and what tools and technologies can we use to you know, better make their customers happy. I'll just talk a bit about some of the AI and machine learning projects that I've worked on.
Yeah, sure. Sure.
So one of them, the defense client came to us, and they had like huge fleets of ships, which they weren't sure which ones were seaworthy or not. So this was the one I was mentioning earlier. In 6 weeks, we developed a drone using computer vision technology to go back and forth through this harbor full of these ships. They were unsure of the seaworthiness, to take photographs and assess whether there was levels of corrosion on these ships. And I will admit the initial prototype wasn't perfect. We only had a 5 megapixel camera mounted on the drone, not quite good enough. But after some iteration, we were able to really, you know, harness all of these technologies. Well, like we didn't necessarily like reinvent the wheel. You know, like a drone with a camera mounted using these you know, machine learning models. That we didn't really create anything new, but we put together these existing technologies in a way which produce some, you know, I'll admit, it's pretty impressive results.
No, that is really interesting. Especially like it sounds a lot more like for like personally, I sometimes feel like it would just always be office work. But that sounds like you've really gone outside and applied the stuff you've done at Accenture.
Yeah, I was
and your degree. Yeah,
like lucky enough to actually get to go there for a day and see it in action, which might not be able to anymore, but that's a separate issue.
Fair. Okay. Similarly, Dr. Sanjay, KPMG is typically viewed as one of the big four accounting firms. So I'd actually like to talk about your role as well as KPMG's team of innovation solutions and ventures, and how that is doing with working with data science and AI.
Sure.
Sure. Yep.
Yeah, absolutely. I mean, I guess I had that impression of KPMG and the other big four, you know, PwC, EY, and Deloitte before I joined KPMG. So, you know, they're the big four accounting firms, and people just think that it's all about accounting, tax, etc. But the reality is, just like Accenture, these consulting companies have a very large practice looking at the application of modern techniques like data science and AI to solve client problems. And so we're no different. We certainly do a lot of work in that area. Now, in particular, I guess a lot of the consulting firms have recognised that no longer can they just keep, you know, applying consultants to solve a problem, so people to solve problems. That doesn't scale. You don't get you know, economies of scale, etc. And equally, some of the problems that are appearing in the client environment are really complex, so prone to human error if you apply just people to them. So we're all sort of looking at, well, how do you actually tech enable these solutions? And so, you know, apply technology like data science and AI to allow you to solve these problems, you know, quicker, faster, in a more scalable and automated way. So to give you an example of that, I mean, we've done some work with financial, with the banks, basically applying cognitive management, sort of sentiment analysis type and natural language processing to analyze the interactions between the banks and their customers to see whether they're compliant with the sort of statement of advice that they provide. So you might recall there was a Royal Commission with the banks, where basically they said, well, look, you know, you provided this particular loan, but your advice was something else. So how do you validate whether the advice and what the product is match up? So you could do that manually. You know, people go through all the transcripts and, you know, go through all the statement advice and then go through the loan documentation, or you can automate that using AI. And so that's some of the work that we've done. We've also done some work just recently with one of the zoos, and what they wanted to do was to actually understand, monitor their penguins. Basically to see if the penguins are under any distress, whether that be through natural causes or they were being attacked by, you know, feral animals. And so they couldn't afford to have someone monitoring the video feed all the time. So using computer vision techniques, we developed techniques to detect whether firstly detect the penguins, secondly detect whether they're in distress. So it gives you a feel for the quite varied nature of the type of work we do. But I guess at the heart of all that is a recognition that technology is really the future of firms like KPMG. And so that's the reason why ISV, which is a division I sit in, Innovation Solutions and Ventures, was formed, is really to develop some of those technical platforms and solutions that can help us deliver solve our clients' problems.
Sure. Also, another thing, I remember you showed me yesterday when we were talking, if you wanted to bring up that slide deck, by
Sure.
all means, feel free to whenever you choose. Anyway.
Let me,
yeah.
host has disabled participant screen sharing. Oh, yeah.
Oh, sorry. Let me, Stephen, if you wanted to just quickly.
If you want, we might cycle back to this, Dr.
Yeah,
Sanjay.
I'll come back to it later.
Thank
That's
you.
all right.
Sure, no worries. And let's go now over to Xin. Xin, as the lead machine learning engineer at Eliiza, how does Eliiza use machine learning and AI to help tackle business problems?
Yeah.
Yep. And what are the like sort of projects as well, if you could also elaborate, like Dr. Sanjay and Kenneth have also done.
Yeah, definitely. So as I mentioned before, Eliiza is also machine learning and AI and data science like consulting firm. So we take clients' projects and then apply a machine learning or data science techniques to solve their problems. I would say that in Eliiza, we have like two kind of like categories in terms of the data science and AI projects. One is more similar to what Accenture and KPMG are doing, is more like the machine learning and AI application. So under that category, from my experience, I've done some a project that to help people to help clients or organizations to process like document using machine learning techniques. So pretty much we use like OCR, while we use existing OCR services to extract the printed text from like PDF documents. And then we applied algorithm to extract some of like the target fields required by clients. And also a step from that is we also apply some natural language processing techniques as well as some computer vision techniques. So combined between, the word embedding, NLP, text tokenization, those techniques with some of the computer vision one, like a convolutional neural network, combine them to apply into some documentation processing project. And the other one would be under that category would be like conversational AI, like chatbot. So we have clients to kind of like build up the chatbot dialogue workflow and help them to use like NLP techniques to like discover intent and like what the customers are talking about in like a kind of like a timely fashion, like recently, what is the most discussed topics. So those are the examples for a more like an ML applications project. And then on the other hand, we also kind of like help the customers to actually, organization to speed up their data science and AI development process. So we are also very involved in some of the machine learning kind of like platform buildings, operations building practice, so that the organization would have a lot of data science machine learning models developed, but they don't have the kind of like the pathway to actually like deploy them or the pattern to deploy them in a streamlined fashion. So we also like have the capability to provide those help some organization to build out that platform so that they could have those like machine learning models go into production in a streamlined fashion.
Yep. Great. And Robert, so you're not specifically into AI, but like a lot of what Amazon does in terms of AWS, I guess, augments what people need for producing models. Would you please tell us a bit about AWS?
Yeah, sure. So yeah, I guess to give a bit more context to this, because if I was just talking about AWS and AI, we'd be probably here for another 3 hours. But specifically, I work for a division known as professional services, and within that, I'm in the public sector. So the sort of work that we do is we go to clients that are in public sector. So that includes government departments, universities, and nonprofits, and we help them with their with technical challenges that they're facing, and we help them find solutions using AWS services and products. And we also work extensively with our partner network to do this as well, which coincidentally, everybody here on this call, their respective companies are also part of that. So I've worked with Accenture before to deliver AI solutions for, you know, public companies, which, you know, working with you know, client data, and they've got a specific, you know, use case that they want to solve, and so we go in and we build a team together with people who are qualified in that area, and we solve that issue. Specifically in my role, I work as a cloud architect, focusing a lot around security and machine learning. So whenever there's a situation that revolves around either of those two areas, that's when I can get involved to sort of help out. But what we generally do at AWS as well is we're all about scale. So when we have organizations or companies who have got a product, you know, that might have a machine learning, you know, an AI product, and they're saying, listen, we've got this, you know, AI that's able to detect, you know, certain features that that we want to be able to employ into a product. How are we going to scale this so that you know, we can get, you know, good, so that we can get at least, you know, some good traffic on it as well. Because it's one thing to say, okay, I've got this model, and, you know, it's running on my laptop, and, you know, I can identify, you know, people's faces, you know, and it, you know, it's able to tell if they're happy or sad. But how do you scale that so that it works on, you know, 500,000 people's machines, or, you know, how it's, you know, inputting terabytes of data at any one time? So we do a lot of work also in scaling in that area as well. Specifically, one of the other things that we also do is we offer like a huge number of services around AI. So I'm not sure if to the people who've never been inside the AWS console before, we offer around 12 unique over 12 unique like AI services, like ranging from like pre-built you know, solutions like being like Textract, which is a way of just like doing optical character recognition or translation, to, you know, SageMaker, which is like an all-in-one solution to get started in the cloud with machine learning. And as somebody who, I did my final year project on a laptop and my desktop computer, and I remember waiting weekends for it to train all of this stuff up, and like going, okay, you know, this is my results for this, you know, for this really important project, and, you know, due, you know, in a couple of weeks, and it's taking me like 12 hours to do one training session. I had that light bulb moment where I did a run on the cloud when I first started at AWS, and I was like, oh, okay, I understand why this is such a big game changer, because it was like instantly, like within a few minutes, it was completely done. So we put our hands in a lot of different areas. Specifically though, in Australia, one thing I'd like to mention is, we do a lot of work with with the universities. One of the things that we're working on at the moment is a new way of doing e-vigilation. So you know, obviously with COVID, everybody's at home. So we're working with a number of different universities around the world, even about how are you going to scale exam invigilation to, you know, being online, and making it reliable and, you know, fair for students, and work, and how are we going to use AI to solve that? So that's like some of the problems that we've been dealing with at the moment, and like we'll be continuing onwards in the future.
Great. And lastly, Dr. Levin, I was hoping you could take us through some of your research that you're currently working on, maybe some of the interesting projects, because I understand that you have quite a few projects going on at the one time.
Yeah, so if it's applied data science, it's mostly about epileptic seizure prediction. So we have, like a few years ago, we implanted a person or 15 people with a brain implant to record long-term brain activity. And in order to try and predict seizures, and seizures are rare events, so they're, you know, even individuals with seizures find them hard to predict. So that's why we obviously put implants in people's heads. And the data is really noisy. There's no pre-seizure signal that a human can identify really. And so we rely on algorithms, ML algorithms, to extract, hidden information in the pre-seizure period to be able to predict seizures, but it's still a really hard problem and a work in progress. And then we look at other ways of doing like neuroimaging that sort of relates to applying machine learning in order to image physiological variables that you can't directly image with current technology. Like you image current sources, but you can't image individual population activities. Like you can think of that being analogous to the activity of an individual neuron in an artificial neural network. We're trying to be able to image these types of variables in the brain from data.
Yep. Yeah, that's really cool. I have questions about the implant. So basically, so you're implanting directly into the brain, or where are you implanting to take
well,
seizure
there's
prediction?
different implants. Like if you're talking about Neuralink, they put like hundreds of microelectrodes into the brain, whereas this implant, you're trying to pick up signals that like neurologists analyze most often, and they're like basically large scale electrodes, like a millimeter in size, that you can put on the surface of the brain, or you can penetrate into the brain, but you would only put in so in this implant, there are only 16 electrodes that we put on the surface of the brain in order to record the signals. And obviously the more signals you put in, the more invasive it becomes and the more damage you can do to the brain. So there's a trade-off there with the information you can get and how long you can have the device in, and how much damage you're going to create and things like that.
And so oh, sorry, were you going to say something?
No, go ahead.
Yep. And in terms of like the predictions, you've got like some machine learning algorithm that does it take the brain, how do I say it? The brainwave data, or is it blood?
No, it's electrical activity of the brain. So put electrodes on the surface of the brain, analyze the signals with signal processing techniques, feature extraction, and then feed that into machine learning algorithms, basically. Sure. And like deep learning, is popular and everyone tries to explore it, but it's not necessarily the best thing in every application.
Sure.
But definitely for brain implants, for some applications, deep learning showing really good results. In our situations, not necessarily that good, but it also relates to the amount of data you've got, and seizures are rare events, so you don't necessarily always have a lot of data.
Yep. Fair. Okay. It's basically 4 p.m. So I wanted to get into the topic of pathways. So this is for a lot of students. We've got, first years right up to postgraduate students. So I was wanting to ask, from your point of view, what is some advice that you guys would have for people wanting to work in the industry? Dr. Levin, if like postgraduate sort of research as well. So from your point of view as well, that would be great. Let's start off with Robert. Did you want to give us some advice?
Yeah, absolutely. I think, and I was just looking at some of the questions that were in the Q&A as well. So hopefully I give a little bit of the context behind some of those as well. So first off, for AI ML, I really do believe that it's becoming a really central part of IT in general, and even if you're not specializing in machine learning, you will be exposed to it in some way or another, doing just normal software engineering work or just IT work in general. So if you really do find yourself trying to get into positions, I'd say the sort of the best way is maybe if you starting off as a generalist and focusing on specific areas, is one way of doing that. And so if you decide to go into software engineering, or you decide to go into big data, and then you find that you think you want to get into some more machine learning, focusing on those type of jobs and doing some extra studying, if your work gives you that opportunity, is always a great way to get into that. However, if you really are dead set on getting into AI and ML, really when you start out, I think the units that you do obviously at university help a bit, at least in getting you into a right mindset. But again, they're not really it's not really entirely compulsory. I think like honestly, the best advice I have is to just start trying with toy projects, and that's how I really started with my career. I not to sound too negative of Monash, but a lot of the work that I do right now, it has nothing to do with any of the units that I actually did, and a lot of the work that I do was started out as like stuff that I learned in my spare time. I learned a lot of web development that I did in my spare time, and that was how I actually kind of got my first job, was having a basic understanding of that. So I really do think that personal study is a good way of doing it as well, because you find out what you really enjoy that way as well, and having that that sort of direction, I think is probably one of the most important parts. In terms of, I can only speak for myself in this area as well, but a lot of the machine learning, at least at the high level, doesn't need a lot of mathematics to work. A lot of it is, if you have an understanding of if you have an understanding of linear algebra, which you can get from, I think, a lot of YouTube videos, and if you buy a textbook and you just have or a popular science book and you're able to read and understand that, I think you're really well ahead of a lot of other software engineers, and having that like basic understanding is a really good way of getting deeper into it. And I think having that basic understanding of a lot of that stuff, like people were asking like some frameworks and like stuff that you can learn to get started. TensorFlow is and PyTorch, really important frameworks that people use to build their networks and things like that. And to really get started on those, you don't need a lot of mathematical understanding. You just need to have a basic understanding of training, evaluation, validation, and how to like process the data, and you're well on your way to building a network. And I can count on one hand the amount of times I've had to use mathematics really strongly to actually solve a problem for my work. A lot of it really does come from on-the-job training, and just being able to, as long as you have the ability to work through a problem, I think that's the biggest sort of like skill that you can have. And that's really just like for any job, just being able to say, okay, I'm going to have to like power through this and, find some resources available and try and find the solution for it. And I think if you've got that mindset, then getting into the industry can actually be quite achievable.
Sure. Yep. And Kenneth, would you like to add anything to that?
Yeah, so just building on what Robert was just saying, it doesn't matter if you do commerce, law, IT, maths, engineering, all of these areas, the lecturers and the academic staff are trying to teach you how to solve problems. And that's really, in industry, that's really the types of minds that they want. That they don't necessarily need you to be able to do that really like the generative adversarial network, not like machine learning model. That might be a very high level implementation, which they don't necessarily need on like a day-to-day basis. But if you've demonstrated an understanding of that area, then it probably means you're pretty good at solving problems and thinking critically about an area, and that they can throw your mind at whatever it is, and you might be able to you'll be able to break it down into the logical components and work through it. But if I had advice for students wanting to work in industry, especially in the area of AI and ML, I think one sort of fundamental component is have some programming knowledge, like at least one language. Once you get one language under your belt, and you know it really well, transitioning that sort of that understanding to any other language is usually not too difficult. But I think one other thing I would mention is getting a good grasp of the breadth of what's out there. So like, data engineering and cloud technology and responsible AI. So that when you come to these types of events, you can really take a lot more away. So, when Sanjay mentions things like centers of excellence, I didn't know what that meant like a year or two ago. Now I have a much better understanding of that. So when he mentions words like that, that sparks up different concepts in my mind. So I think gaining that breadth of understanding of what's out there, so that when we're trying to communicate this to you, you can figure out what you like and what interests you, and where you might like to go from there.
And how have you like gained this breadth of understanding? Have you gone to career fests and stuff like that, or?
Yeah, so that's one way. Another way is just reading Wikipedia articles, just trying it for yourself. Just trying to sponge and absorb as much information as you can. And yeah. I mean, being around smart people is always good, because they'll always be challenging you and to think more about the breadth of what's out there. But yeah, that's a hard one. I don't quite know.
Sure. No worries. Thank you. What about you, Dr. Sanjay?
Look, some really great points there by both Kenneth and Robert so far. So probably I'd say that grades only get you so far. So grades get you through the HR filter and get you to to the next stage of a recruitment process. What really differentiates one candidate from another is their practical knowledge. And that's demonstrated through what projects they've done. Whether that be university projects or whether that be Kaggle comps and things like that. Because what that shows is the ability to work with others, the ability to solve problems, the ability to apply your knowledge to solve problems, etc. So what I encourage is really keep your grades up, because that sort of gets you through that first gate, but really get involved with solving problems, get involved with projects, etc. I think the point that Kenneth made about critical thinking, the ability to communicate, problem solving, that's absolutely what differentiates one candidate from another when we're recruiting. I think the other thing, just to Robert's point about, the maths, I mean, certainly you've got to have a good grounding in maths, but what's increasingly more important, thanks to companies like AWS and GCP and others, is the ability to understand when to apply what algorithm to what problem. So do we use a deep learning approach, or do we use random forest, or so the ability to actually understand the field well enough to know that for this problem I apply this technique, for this problem I apply this other technique, that's really, really important. In terms of advice, in terms of getting into industries, a couple of things. First things, pretty much most companies will have, particularly the bigger ones, will have work experience programs. So I encourage you, if you're first, second, third year, look out for work experience programs. That's a good way to get into a company, understand how companies work, how projects in companies work. Some companies have internships. We have internships. So this is a longer period where someone might work with us. Work experience is generally just during the breaks, like the summer breaks. And then obviously there's the graduate programs as well. So there's often multiple ways in which you can start to get industry experience. But I guess the key takeaway I want to leave you with is get that practical experience, demonstrate your ability to solve problems, demonstrate your ability to work with others and communicate. Those are the things that will differentiate you from the technical skills, which are, you know, almost a given. We expect people to have those strong foundational skills. It's those other bits that really differentiate you.
Great. No, that's some really good advice from all of you so far. How about Shin? Do you have anything to add to this?
Yeah, I think there's a lot of like good points mentioned by Robert, Kenneth, and Sanjay. I just to add on to that is that if you really have like a area that you really want to go deep and try to like explore more, and later on want to take on more like advanced work, I would say if you want to kind of like want to pursue in like the academic research PhD for a particular area, if you are super passionate in that, for example, like robotics, you know, reinforcement learning, and even like autonomous vehicle, that line of work, I think if you have that passion, if you think that suits you, like going to academic research PhD, do some in-depth work, and then later on you go back into industry, maybe you could kind of like yeah, just take on like the passion a bit deeper, and then you could go into, you know, that area more like a advanced area, or more like with more expertise, I guess. So that's like one way, but on the other way is that if we want to get more like commercial industrial experience from now, I guess as like Robert touched on, like projects, from my personal experience, is like project, whether it's like for work or for like personal project, is really important. And especially if we want to get that full experience, I usually call it like a full stack machine learning. It just from all the way from like you have like a software engineering foundation, and then the next thing will be like gather some of the you know, understanding theories behind like machine learning, AI, and then you take on a project. I would advise not to use like something like MSNet that's already prepared for you, like the data prepared for you, the networks prepared for you. You just need to run it. It's good to get into it, but I think it would be better if you could kind of like pick on like a customized problem. I have this problem, and you have like, you know, you need to collect your own data. You need to find a network algorithm to solve that problem, try to find that you know, algorithm, and then try to find the data, try to connect all the dots, try to, you know, train the model yourself, solve the problem, and then some kind of like, you know, after the trained model, you have some post-processing steps, something like that. So you have like the whole full pipeline that you go through with a customized problem. Potentially is more suitable for, you know, your personal interests. Just go through that, then you would learn a lot. I mean, the learning curve probably would be a bit steep at the beginning, but I guess go through that process, because I think I've been through that process and I learned a lot in terms of like picking up like, you know, the technologies, the techniques, the how you do things. So I guess that's yeah, I guess that's my add-on.
And it would, yeah, doing a project like that would really boost your confidence up as well when you're in, I guess, like an interview style situation where you can draw from a lot more personal experiences on top of your university. Great. And Levin, I would like to ask you what advice you have for students wanting to pursue further research or postgraduate opportunities.
Yeah, sure. I guess just following up from what everyone else was saying, I think it's probably pretty important for someone to figure out what application domain they want to specialize in, because people, you know, are getting these degrees and they're getting all the technical skills, and it's good if you can, it's great if you can figure out which algorithm to apply in different problems, but you probably only get that through experience over time. I think you also need to have a, you know, a domain where you feel like you want to be an expert in, whether it be finance or, I don't know, logistics or whatever. You want to somehow specialize in that, so that you can, you know, you can't really build a data product unless you know what, you understand the data. And then in terms of degree programs and stuff, in one of the other units we had an assignment which was based on a Kaggle survey, and it seemed that most data scientists at least had a master's degree. I don't know how that relates to Australian industry. I know a lot of Australians don't do master's degrees. They prefer to just do their bachelor's and go into the industry. Yeah, so I don't know what it's like in terms of whether students are expected to have a master's. Like at Monash, we have the Masters of Data Science degree, but there's a lot of international students, mostly international students doing that degree. And obviously, yeah, there's a whole raft of different possible PhD projects that are available through Monash. Like people can be doing health projects, business projects, industrial projects, environmental projects, applying ML to the different areas. We sort of have 4 main threads that sort of relate to ML and AI. There's basically the ML and deep learning group, which specializes in things like time series data, obviously deep learning, and Bayesian modeling, probabilistic modeling. And then there's a more specialized vision and language group, which really, is applying things like NLP and computer vision, and deep learning is pretty heavily involved in that as well. And then there's AI, which is like chatbots and things like that, and reasoning as well as, ML. But and then there's optimization, which is about how you optimize all your different AI and ML algorithms, basically. So there's sorts of things that people can sort of choose to study at a higher level. They're all probably relevant to sort of a data science AI pathway. But I know in Australia, we don't have a very strong manufacturing focus. We're more on delivering products. So a lot of people, like it might change more with the data science and AI, but in terms of engineering, a lot of engineers typically, a PhD is not necessarily required for an engineering job in Australia. I don't know if the panelists have a different opinion on that. I think more with data science and AI, it's a bit more technical, and possibly if you have a PhD, it probably is more valued. But based on that Kaggle survey, it seems like, having a master's degree is a sweet spot.
I might just add to that, if you don't mind.
Yeah.
Is that right? Yeah, so I guess in terms of having a PhD and working in engineering, certainly it's not a prerequisite. In fact, when I started out my career at Motorola, I used to hide the fact I had a PhD, because the perception was, well, you're an academic and you can't solve real world problems. But what I do think about PhDs is that they give you the opportunity to solve really deep problems, and they really train you in solving complex, deep problems, which is really useful in the workforce. But here in Australia, we tend not to value them as much as other countries do. Like you go to Germany, for example, PhDs are highly valued in Germany. So I think in Australia, what I've seen over the years is what's really valued is that real practical application of your knowledge and skills, and you often get that through masters, or you just get it straight out of university, going into the workforce and applying your knowledge in the real world in projects.
Sure.
Yeah, I also want to touch on to that, if that's okay. Is that because I think I'm from like a little bit different. I have experience. I'm working like startups, and I guess like PhD. From my experience, is very valued in a particular field, especially for like a particular a problem or domain. Sometimes, like I guess startup would choose kind of like a more novel approach to kind of like solve problems, and they do require like the people with like a deep technical skills in that field to solve like some deep complex problem, and to have like a more innovative novel approach to problems. So I guess in that. From my experience, in that sense, I guess like PhD in particular field, for example, like computer vision, is valuable in some area, or like, well, to me, in my experience, like startups.
Yep.
Yeah, so I might have come across incorrectly, but certainly in just general engineering, I think what I said, I stand by. But certainly in this area, and this is one of the areas that I do think having a PhD does differentiate you, particularly as you mentioned around computer vision and even the stuff around NLP, etc. In fact, at my last even in KPMG, my data science team almost all of them have PhDs, and certainly at my last organisation, all of my data scientists had PhDs. So yeah, this is probably one of those areas where having a PhD does differentiate you.
Sure. All right, let's quickly move on. Now we'll talk a bit about the future, but these two sections might get cut short depending on our time, but hopefully not, because they were the ones I was waiting for. So basically, I guess I wanted to know how you guys see the industry changing over the next decade, and what you guys are most excited for. Like, we'll try keep this quick, but not too quick, just so that we can get through a lot of it. So yeah, would you like to start us off, Kenneth? What excites you most, I guess, in the next decade or so?
Yeah, okay. So thinking about how technology is going to change over the next 10 years, it's a big question. You know, if we just go 10 years back, at like where I went to university, there wasn't even a subject called, like dedicated to machine learning. And now at the University of Melbourne, there's I don't know, maybe a whole degree, a master's of data science. So it's going to change a lot. I think one area which I think is going to be present, no questions asked, is the ever-present concern of security. So as everything goes more and more online, we all have a Facebook, a Twitter, an Instagram, all of these things. There's us, the real human Kenneth, but there is a digital copy of me, which is composed up of all of these different social media profiles and email accounts and work accounts, all of this combined. And that, I don't necessarily have control over how that information is used. But I think going forwards, gaining more control over something which really, is my intellectual property, I guess you would call it in many instances, is going to be paramount in how we develop systems going forwards. And like designing security into the system at every single level, so that at no point can this be compromised. So I think security and this area of responsible AI is just going to be an ever-present conversation in every technological implementation over the next 10 years.
Sure. Yeah, that I guess, like, we'll talk a bit about ethics and AI. But before I did that, sorry, I'm just gonna scoot over to Levin. And I really wanted to actually ask you did you find any interesting overlap between your research and data science as well as your work in neuroscience, especially with how the field seems to be merging? Yeah.
In terms of the future of AI, or just generally?
Yeah. So like for example, you were telling me about technologies that you can implant into the brain, like for example, Neuralink, how they're trying to, like, I think Elon's whole thing is having this device so that you can merge with AI. What do you like? Do you find any overlap between?
Yeah, I mean, basically the issues are the brain-machine interface. So if you can put enough electrodes in and the brain can tolerate them for a long enough time, then basically you can read the mind. Essentially, you won't know exactly what the human is perceiving, but you will be able to pattern recognize the signals that you're recording from. And the more signals you can record from, the more you can infer from what that person is thinking or whatever. And use that to either control them or have them control other things. It's all very, very possible. It's still like The thing is, having brain implants for a long time is hard to do with current technology, but maybe in 10 years you could have brain implants for a long time. So we had patients implanted for 3 years, but the types of electrodes weren't as invasive as what you might have in a neural link that would be required to actually analyze individual neural activity, and that's at the level where all the information processing is going on. You need to be able to sort of get to individual neurons, or even just sets of individual neurons, to be able to infer, or to analyze the signals related to information processing.
Yep.
So what object someone's seeing, or what someone's trying to grab out and reach.
Sure.
It's definitely very possible to augment people, but the ethics about it, I think, will set barriers for a long time. It's only going to be about augmenting people with medical issues for a long time.
Yeah, yeah. And that takes me to Dr. Sanjay, because Dr. Sanjay actually published an article titled Human Rights and Technology in 2020 and Beyond. So in this article, Dr. Sanjay, you provide some estimations and warnings about these new technologies, including AI, blockchain, as well as neurotechnology. So would you explain to us some of the risks that you see given the pace of technological innovation?
Yeah, sure. So I guess one of the biggest challenges, technology moves much quicker than sort of the legal and regulatory frameworks that trail behind. And so, we all often get excited by the ability to apply these techniques to solve problems, and that's great. You need to drive innovation and encourage innovation. But we're starting to see, particularly with AI, we're starting to see now where people are starting to question the ethics behind some of the applications around AI. So if you take, for example, image recognition or facial recognition, right? So there are some very legitimate uses of that capability, and particularly in things like the medical field or surveillance or medical field, but then there are some other applications of it. So, for example, in the way that it's being used for surveillance of minorities in certain countries, where that same technology is not applied in an ethical or responsible way. So, I think that there is a lot of work to be done around looking at things like responsible AI or trustworthy AI or ethical AI frameworks. There's some thinking that's already started across the world. Here in Australia, our Commonwealth government has issued a framework around ethical AI. But how do you then translate that into practice? I often use a phrase: just because you can build it doesn't mean you can use it. And the reason why I use that phrase is really to reinforce some of these challenges. So there are examples of where biased data is used. So there's a well-known example where someone used an AI algorithm to support their recruitment process. And the data they trained was biased, and so the results was biased in terms of the people who were filtered in and filtered out. So that's just one example where responsible AI has a role to play, or trustworthy AI has a role to play. But it is it's not a black and white issue. Ethics is never black and white. It's very contextual. So as I said, that facial recognition example is one where in one context it's completely appropriate, in another context it's not. And that's what makes it quite challenging. And so I think that's why we've really got to take a use case based approach to it. What is the use that you're looking to apply these techniques to? And that's a challenge. That's a challenge for any emerging technology, right? So whenever you have a new technology, the application of that technology is evolves at a far greater rate than the controls around it. But the reality is you need to look at both sides of the coin. So
Sure.
both the controls as well as the application.
Of course. Yep. So it's getting to be around 4:30, and we want to get the audience to ask questions. And I know my section's gone for quite a bit. So Shin and Robert, I know you guys might have some thoughts on this, but I would like to actually open up the chat and maybe get Stephen to start moderating. And if we do have time, we'll swing back around and ask you guys about your thoughts on the future of AI. So please, Stephen, could you take it away from me?
Thanks, Sahil.
No
And
worries.
thanks to all the panelists. That was some really fantastic answers to some really interesting questions, especially this last topic about the future of AI and ethics. I guess we could talk about this for hours because it is something that's, I'm sure, on all of your minds. And I think it's good that companies are thinking about ethics in their day-to-day work. So yeah, we have a lot of questions being asked. I think more than 20 have been asked so far. And unfortunately, I don't think we are going to be able to answer all of them in the next half an hour. What I will say is I can see that both Kenneth and Rob have been answering questions via typing. And I do suggest I might go through question by question and target certain people. But if you do see a question that is directed to you and you would like to type a quick answer, you can do that also. And to anyone at home, just to reiterate, you can press the Q&A button to post a question. Make sure that if it is directed to a particular representative or company, make sure you write that down too. And once again, apologies that we can't answer all the questions. So I might stick on the topic of ethics for the first question. I think, sorry, give me a moment. I think John had a question about AI and ML ethics, and he asked, how do panelists minimize discrimination bias in the models that are used? And what ethical frameworks do you use to guide model creation? So I might actually ask Shin from Eliiza that question. I know, Eliiza, on your website, you state that Eliiza is very focused on ethics in all of your consulting decisions. So what are some of the practices that you use to avoid things like observation bias with your solutions?
Yeah, definitely. So I guess that's another thing that is like really important in terms of in our ML and data science practice in Eliiza. It is the ethics AI and responsible AI. And our CEO actually has a podcast. James Wilson has a podcast to talk about the responsible AI topics. In terms of in our project and in our practice, we have, first of all, for like responsible AI or like bias, to me and to us, it's like we take on it as part of our algorithm or data science machine learning development process. So it's not something that you should consider as like an extra thing that, oh, you need to worry about. To us, it's part of the process, part of the procedure. And think of it like more like a technically, it's like another dimension in the algorithm that you should be considered to make it fair, to make it more accurate, to make it like more comprehensive in terms of the model development or like the algorithm development. So that is like our kind of like principle as part of the process. And we treat it as same as like your feature engineering, model development, model training is same as part of those, as part of the steps and process. And then the second thing in terms of like more concretely, how do we do it? We use like some of like the tool, like open source tool, for example, like Liang, or some of the more like the bias tool that we use them in our kind of like a project or development process to kind of like understand the data better, and to kind of understand the data better, and to hence like lead us to make a better decision in terms of how we develop the algorithm. But that is not always the case. Sometimes we don't have control of the data in terms of like the algorithm that we use and the solution that we provide. So we always also have kind of like a break in terms of like how to control mitigate the bias in the model or algorithm that we develop. So if we don't have control over the source, and then we kind of like have some control on the outcome, so we put a break there to make sure that for example, the results come out of a solution or a model is actually, we check whether it's like bias. If so, then what should we do to kind of like mitigate the risk generated by the solution? And also that's more like a solution side of things. And step back, and we also kind of like have like a responsible AI framework. So we did actually take a project. We actually developed a ethic AI framework. That project is more for using facial recognition techniques to kind of like determine people's age. So that for that example, we have a lot of like, we need to consider, you know, people from different backgrounds and, you know, different race and different with different costumes. So there's a lot of things to consider, and in terms of like age verification, and there's lots of like kind of like potential risks for like the harm that the bias can do from that piece of work. So we actually develop a kind of like a ethics framework to have as like assessment framework for that solution on the ethics side of things.
That's great to hear. And it's great to hear that a few companies, it seems, are looking at these ethic frameworks. In particular, I know Dr. Sanjay, with this article that you posted to the Human Rights Commission, it does cover a lot of the same points that seems Eliiza Consulting is also looking at. That's great. I might move away from ethics for now, but stick with Shin, because you have another question essentially asking, and I guess some other people could chime in here, with AI, there seems to be a wide array of different research articles coming out, different papers, always new solutions for consulting and for AI. So with this fast development in the field, does machine learning or AI roles involve a lot of self-learning? And what are some of the processes that you go about to keep up to date with the latest research that's coming out in the field?
Is that a question for me as well?
Yes, if you give a brief answer, that would be great.
Yeah, definitely. So I'm that kind of person that will actually read the paper, and like, for example, the GPT-3 like model just came out, and I would want to understand what's like the actual, you know, model architecture, like the technical side of things behind it, or like and beyond, and at a broader impact. So I will read the paper and try to understand a little bit more. I do not understand that there's like a lot of papers coming out, and it's like sometimes it's hard to you know, read all of them. But I guess for my experience, I have a certain field that I'm interested in, and I follow the news a little bit more a bit more closely in those fields, and then I would kind of like selectively choose like under that field, if like some kind of like papers, I would go through them and think that, some of the techniques or some of the use cases that are more applicable to my interests or my day job, then I will read those papers. So it's like more like a filtering things. And I guess during like my work or like with like client projects, sometimes I have this problem and I think I know the solution. I have this problem and I think I know how to approach that solution, and I would kind of like try to do more research in terms of whether there's any papers in that field, or to potentially be able to solve the problems that I have. So I will read those papers, and of course I will read the one that's more like up to date. So I guess it's a two-way. One is like generally I have interest in those fields, I would selectively read those papers and understand a little bit more. And on the other hand, it's like I have a problem in hand, I would go into the research and to find out more work that has been done in that area.
Fantastic. And that leads me on to my next question that was asked by Scott. Scott asked, have you or any of your colleagues experienced imposter syndrome when working in the field of AI? I might direct my question to Rob for this one. So for those who don't know, imposter syndrome is the feeling of not being good enough or smart enough, which kind of goes against all the evident success in your role. And it's a big part of IT jobs, because it seems like with a lot of new research coming out, there's always new things to learn. And I don't think there's enough hours in the day to keep up to date with the latest technology that's coming out in the field of AI. So Rob, have you experienced this, or do you know people who have experienced this? And what are some kind of solutions or some tips to overcome imposter syndrome?
Yeah, sure. I think everybody always suffers a little bit of imposter syndrome, no matter how experienced you are. there's a saying that we have at Amazon that working at Amazon is like drinking out of a fire hose. You just can't, right? Like absorb all of that knowledge that's coming at you. You know, you got to sort of like dip your head in a little bit and just try and like, you know, grab a drink and then pull it straight out, because you will, you know, if you stay in for too long, you're just not going to be like, you're just going to get overloaded so quickly. And I think like for ML, that's like the same really as well. I mean, except, you know, the fire hose is literally all the papers that are coming out. I've seen some of the, you know, the ML engineers. I actually have a friend who works at Eliiza, and every time I see him, he's got his head like buried inside of a paper, just trying to like absorb all of the knowledge. And I'm just like, this is crazy. Like, and for me, like seeing that, I'm just like, oh man, should I be reading more papers as well, or doing all of these things? But you kind of just got to, having that understanding that everybody is sort of going through that process as well helps. I sometimes use it as inspiration to sort of to learn something else, and say, oh well, maybe I can, you know, maybe I should learn something else, and you know, I'll sit down for an hour and I'll might learn something new, or you know, dedicate like a couple of hours a week to doing something else. But I think it's always just important to know that everybody has it, and that it's a somewhat natural part of working in such a fast-paced field. And you know, whether or not it should be or not is a different question. But I think knowing that everybody else has it is important as well, because we all reinforce it with ourselves, and we all say, yeah, no, it's okay, don't worry, you're not expected to know this. And yeah, having that just sort of reinforcement that you know, it's and telling other people, even if you think you've got imposter syndrome, just being with other people and saying, listen, like, don't worry, I'm struggling with this as well, is just such a relief sometimes for people, because they're like, oh, thank God, because I was struggling with it as well. And you know, you'll always find that that's the case. So a piece of advice my manager gave me was that if you're in a meeting and you've got a question, like specifically, it's like chances are that there are other people, like everybody else in the meeting is going to have that question as well. And you can extrapolate that to basically all sorts of like business practices as well. Like if you've got a question about something, or you're confused about something, or you're feeling like overwhelmed, chances are so is everybody else, or so are a lot of people. And so you can use that as a way of, you know, bonding and building a better like you know, experience overall.
That's some great advice. I think you've covered all the main points there. We might shift to Dr. Levin. You seemed to open up a bit of a can of worms when you started talking about consciousness. So we've got quite a few questions about that. I just wanted to focus on one and get somewhat of a brief answer, because I know we could be here all day talking about this. But this one's from Anmol, who asked, as someone who's deeply interested in consciousness, I'm keen to hear how your understanding and appreciation of consciousness has evolved over your career.
Yeah, I still don't understand it. All I can do is figure out what's going on in the brain while we're awake and asleep, and when we experience things like seeing an object or something like that. Record the signals, and it really is sort of a correlates of consciousness, and you can try and create mathematical models that explain what's going on to the activities of the neurons in the brain, but you're always limited by the imaging technology or whatever in terms of what you can actually describe, and you still, there's just theoretical boundaries for actually, you know, philosophical, I don't know how you describe it, but intellectual boundaries to being able to understand consciousness. Like I can't prove that any of you are conscious, even though we sort of take it for granted that we all are. Yeah, and that's one issue with the ethics of AI. We can't really say if an AI is going to be conscious or not. And another worse issue is that behaviorally, like consciousness, you believe to require, like in the brain, it requires feedback mechanisms before things enter consciousness. But when it comes to like neural network theorems, there's theorems that show that basically feed-forward networks can do the same things as feedback networks. So if you need consciousness for, if you need feedback for consciousness, it doesn't, you can basically have an AI that can basically reproduce the same behavior, and it can be a feed-forward AI. And if you ask it if it's conscious, it can just tell you that it's conscious, because a feedback system, which is supposed to be conscious, can also tell you that it's conscious. So there's a lot of complicated issues when it comes to thinking about.
For sure. You may have just blown my mind. I don't know how we move on from that question back to the field of AI, but let's go the complete opposite and get very specific. Cameron had a question asking, why do you think there's such a disconnect between data engineering services, such as databases, Spark, etc., and machine learning frameworks such as PyTorch, transformers? And what is the best way to get around this for projects working with large amounts of data? I wonder if anyone can answer that question. Maybe you, Kenneth? It's quite a specific question, so if no one has the right answer for it, that's totally okay.
I'm not quite sure what they mean by a disconnect between these two. I mean, they're both very, very important parts of sort of the technological solution that you would create. If somebody else wants to jump in.
They're probably taught separately, sorry.
Yeah. I think I might have one perspective on this, which is, and not to badmouth all the PhDs that are also on this list, but I remember when I was doing a lot of my final year projects and looking at people's referencing code, there's definitely a disconnect between, I think, a lot of how software engineers are taught how to code and how PhDs or people who are in the real world actually do code. And I think that disconnect sort of plays a part into that as well, because the people who are writing some of these libraries are coming from professional experiences where they might not, be trained in specific patterns and things like that, which makes it really hard to integrate with other technologies. So I think, and we're starting to see that though close a lot now, because the fields are starting to overlap so much now that people are able to have a skill set that allows them to combine the two. But at least that's my perspective on that, at least.
For sure, thanks for that. Moving on, we've just talked about some technical things to do with software. I wanted to talk a bit about soft skills needed. So I think it was, sorry, whenever someone posts a question, the previous question gets lost. Somebody did ask, what type of skills are desired when going for grad roles in the fields of AI? And maybe particularly in soft skills, what skills are desired and how do you think people can gain those skills while studying at university? So we might move to Kenneth for this one, start off.
So there's a whole range. I'll just point out a couple which basically are, doesn't matter what industry or company you go into, they'll be important. Number one would be agile methodologies. So knowing how to approach a problem with a, fast-paced mindset to get the minimum viable product out there. Make sure this goes back to the 80-20 rule. If you can get the minimal viable product out there, you can make 80% of your users very, very happy. And then 80% of the work is involved in making the last 20% of your users happy. So that really goes back to approaching a solution with agile. Another one I'll mention is design thinking. This is absolutely a sort of soft skill which is applicable to more than just the workplace. Like it's one example would be thinking about what you do in your day and what each of these activities actually contribute to, and which ones don't contribute to anything and can maybe be relegated to the don't do pile, and figuring out what things you do in your day which actually really encourage you and motivate you. So I think agile and design thinking are two soft skills you definitely want to look into.
Awesome. And Dr. Sanjay, did you want to add anything to that about what skills in your team at KPMG do you look for when you're hiring new graduates or even people that have been in the industry for as long as you have been?
Yeah, okay. So I think just adding to Kenneth's point, I think they're really good points. Things like we mentioned before, that ability to solve problems, the ability to think critically. So, a lot of times now what we see is people look at things in a fairly superficial way because, that's what you get, go onto Wikipedia or whatever, and you get the first response, or do a Google search, you go for the first response. But it's that ability to actually think a bit more critically. It's the ability to communicate with others, the ability to work with others. It's the ability to think creatively. The problems that we're trying to solve these days are really complex problems in which there's not an obvious answer. So how can you think a bit more creatively? How can you draw upon expertise from other disciplines as well? Pretty much every problem nowadays is a multidisciplinary problem. So you're applying, maths, you're applying software, you're applying domain knowledge, whether it be medical knowledge or legal knowledge. So it's quite a multidisciplinary environment. So the ability to work with people who might not necessarily come from the same domain or tech or background as you. I think all of these things really differentiate someone from others that are also competing for the same sort of role. So I'd encourage people to try and get exposed to working on projects, get exposed to different ways of thinking. Things like this are great because it exposes you to 5, 6, 7 people who work in lots of different fields and companies and look at the problem from different perspectives, because that's really what's required to solve problems in the real world.
Fantastic. We might go to one final question, and that's the one that Connor asked. So Connor asked to Shin, I'm someone who's very interested in either working or gaining work experience at a startup. How would you recommend I go about finding AI startup opportunities? And do you have any startup specific tips on applications?
Yeah, definitely. I was literally typing the answer, but yeah, great. So I guess for AI startup opportunities, it's a little bit tricky to find those opportunities via traditional job ads. I'm not saying that they don't exist, but it's a little bit harder. And it's a little bit harder to know whether that's a good opportunity or not. So for my experience, I found mine, 2 of them via a slightly different route. The first one is through a startup event. There's a startup Catalyst event happened in Brisbane. That's where I used to live. So I went to attend that event and then talk to people, the other startup Catalysts, and also there will be some people that are actually looking for talent attending those events. So you could actually talk to the founder, the CEO, or people. Mainly the founders of some startups. You could talk to them and see what problem they're solving, and so that you could get a sense of whether you would be interested in working for them. And the other events like that is meetup or tech conferences. So those would be the places I kind of would like to attend and get some exposure to the startup scenes. And I found my second one via some tech forums or blogs. So I just mainly kind of sometimes there's a job tab there that's people, or especially founders in a tech savvy startups, they would post the job ads there, and sometimes I would go through the forums, read them, and then found the job ads and which seems to be interesting to me, and then I will apply via those. And in terms of the tips, I know that from my experience, startups value a fast-paced working style. So be able to kind of get things done in a more a fast pace, and also they value that you'll be able to kind of take on more a full stack piece of work. So not just a focus on one component, but maybe a little bit broader spectrum in terms of what you're doing. So kind of if we want to, for example, ML model from end-to-end development cycle, those I would say those are the 2 main things in terms of working in a startup. And if you could show them those kind of characteristics in your application, you might have a better chance.
Fantastic. That's a great answer. You know what, I'm going to ask one final question to Sanjay. Sanjay, on your website on the article that you posted, sorry, on your site. It says Australia's digital innovation roadmap is forecast to deliver up to $315 billion in gross economic value over the next decade. Monash DeepNeuron, we're a team, as we said earlier, of multidisciplinary students from backgrounds not just from engineering and IT, but from medicine, science, and hopefully in the future from the arts. What advice do you give to students our age to get more involved in AI? And do you think it's important that this field is working collaboratively with other disciplines?
Yeah.
Sorry, and also Beck just messaged me. We do have an art student. My mistake.
So yeah, great question. Great way to wrap up. So firstly, I'll just give acknowledgement to Data61 and Alpha Beta Consulting who did that report on the digital future of Australia, the $315 billion opportunity. The key thing is that these technologies are ubiquitous. They're being applied to every single industry out there, whether it be, you know, energy and mining, or whether it be medical field, or whether it be, you know, intelligence community, as I mentioned before. So I think, you know, the opportunity to get involved either as an AI practitioner or as someone who uses AI to solve domain-specific problems is just going to exponentially grow. And that's the thing that's really excited me about this whole field. And just to make it like a bit personal, so my son is in year 12. He, in fact, just texted me today. He's been accepted into advanced computer science at Adelaide Uni. He did his research projects on the ethical use of AI, and you know, we were having these conversations about, you know, why, you know, what sort of field do you want to go into, etc. And the thing I was explaining to him, and it was, I literally remember this because we were on a holiday in Singapore a few years ago, and we were walking down the financial district in Singapore, and I was pointing out, you know, all the, you know, Rabobank and HBS and all that sort of stuff. And I said to him, well, even if you go into computer science, maths, or data science or AI, you can work in one of these banks. And that's because financial services are one of the biggest users of AI technologies, as is the medical field. You know, we were talking about startups. There's a really great startup by two friends of mine called Precigen, Life Whisperer. So they're using image analytics to determine whether embryos are going to actually be successful. You know, so that's an application in health. So the founders, so one's a medical health science person, and the other one's a computer scientist. So even if you're in arts or medicine or whatever, your field will be impacted by these technologies, and in a positive way, in a really exciting way. So I think all of us can benefit from that. And as I said before, solving these problems is a multidisciplinary thing. You've got to bring together the domain experts with the technology experts to solve these problems. So I think no matter what field you're from, this is an area which is going to be relevant to you. So exciting, really exciting time to be involved in this area.
That's so exciting to hear about, and really awesome that I guess we're all kind of on the same page here in terms of how AI is for everyone, and how moving forward we need to make sure that we're collaborative with all fields, because the potential is really exciting, I guess. So I guess that wraps up the questions. Apologies again to everyone that submitted a question that we didn't get a chance to answer. I want to say a big thank you to our 5 panelists today for the fantastic answers you've given in areas such as your background, your current jobs, AI, ethics, the future, and these more niche topics that we've been able to discuss over the last half an hour. I just want to pass it over to Beck for some final words from Beck, who is our team lead. Thank you.
Thanks, Stephen. I'd like to also extend a big thank you to all our panelists. I'm sure I and a lot of people here have learned a lot more about AI in industry from all of you today. Given that we can't all applaud, I do invite you all to say thanks in the chat. These panelists have been really great today. As I mentioned earlier, we are a student team who's always looking for more passionate and talented students. So if you're interested in applying, make sure you get your applications in before close of business tomorrow. Our recruitment will be closing then, so make sure you get that in on our website. Whether or not you're a student, if you're interested in learning more about what our project teams have been up to over the last semester, I'd invite you to all join us at our end of season showcase, which is coming up on November 11th. We'll be getting to hear from all our different project teams. There'll be a chance to ask any questions you have about the projects themselves and the techniques they're using. So do follow us on Facebook and LinkedIn. We'll be posting more information there. And if you have any general questions about the team, if you're interested in collaborating with us in any way, please don't hesitate to contact us. You'll find the contact details on our website in the Contact Us section. I've got a final thank you for everyone here who attended today. Thank you for being part of our AI Q&A. And I've got a really big thank you to make to the sponsorships team at Monash DeepNeuron. They've worked tirelessly to get this event together. So thanks to Sahil and Stephen, who were part of the hosting of this event today. So thanks to you guys, and also to Scott and Connor, who have been working hard behind the scenes as well, making sure everything runs smoothly. This does bring us to the end of our Semester 2 AI Q&A. So I hope you guys all enjoyed this event and hope to see you all at the next one.
Great. Thank you.
Thanks, everyone. Wonderful.
Thank you very much. It was great.
See you.
Thank you.